This conference will now be recorded.
Hi folks, welcome to the OCP NIC Community Update for the month of May. Today we have a pretty full agenda. We'll first go through PCIe Gen 5 thermal test fixture and also um, the SI test fixture from Dell. And then we do have a big discussion regarding TSFF challenges and the solution. We do have some offline sync up and today Anna gonna bring us some solution proposal from NVIDIA. I will give a short update on the SmartNIC Summit. And last but not least, we do have iPass Lab coming in to talk about their PCIe Gen 5 SI test fixture and also the test service that they offer. For those who know, in the past we have been using UNHLL test services, but since they no longer support the model, I think it's a good idea for us to bring in another vendor to share out with folks so that in case folks want to do that kind of testing, you know who to go to. Okay, let's go through it. First up, Jason.
Yeah, just provide a few updates. We finished doing PCI Gen 5 testing against the thermal test fixture. Uh, originally when the TTF was released, it was rated for Gen 4, but it was designed with Negtron 6 material in hopes it would work for PCI Gen 5. We procured 2 cable assemblies. And by the way, Damien, I don't know if you know, but your slides disappeared. Uh,
Oh, my
we
slide
procured
disappeared. Oh,
yeah, we procured 2 cable assemblies, one from Samtec, the other from Amphenol. Tested with both. Uh, Samtec was a 30 centimeter, which is about 12 inches for us U.S. folk. Uh, that one's available publicly. And then Amphenol has a 6-inch we procured. Both of those using against a Dell R760 with an NVIDIA sample, passed both bit error rate and margin testing. Uh, I will note, so as opposed to saying these are all adequate for everyone's use, there is going to be some dependency on the overall channel budget between the DUT, the cable you select, and your system. So that's something that you just have to factor if you're going to be doing this sort of testing. But in all signs, it works pretty well. There has been some discussion about possibly updating the TTF. If there is community support within the subgroup to do so, based on either some of the items that'll be presented here in a little while, or for some other aspects. There were a few features that weren't implemented on the TTF, such as there's 4 resets. The 2, 3, and 4, or 1, 2, and 3, were not connected to anything. They're no connected. We do want to eventually address that. So if there is any updates to the TTF, we will improve the channel loss across the TTF within that system to improve overall channel, but it just has to be factored if you're doing this sort of testing with PCI Gen 5 solutions.
okay. Is there an easier way to kind of spec out how much channel loss we have on this setup so that the folks know on the other setup is how
Yeah,
much then they can add on?
yeah, I'm gonna have to figure out how we're gonna do that. I can probably get the amount of loss that's across the current TTFs, and then the cables themselves. You can get that rating from those particular cable vendors. They don't provide that by default within
Mm-hmm.
their data sheets. And then it's really up to the sample, the DUT, and then the system that you're using, and being aware of those numbers. But one thing I can do is try to get the TTF number specified. I just don't want to commit to having that done timely, because right now we're pretty impacted on signal integrity resources, which I'll bring up in the next slide.
Mm-hmm. See.
Okay, on the test fixtures that Dell is providing for the community, uh, So we've had the CLB, Keysight and Broadcom had received samples. I presented this last month of having passing within tolerance impedance capability. We are now in the process of releasing these designs. We're working on a user's guide. Within it, these schematic and PCB Gerber package I had provided through a OneDrive connection to anyone that's been wanting that. That same information with the addition of a user guide will be basically given and presented out to the wiki. Additionally, IOL has been providing the Gen 3 and the Gen 4 equivalent for sale. They are in discussions right now and are coordinating for retail sale of this same fixture. They will be using the same assembly and PCB vendor that we used for our designs. They'll be using the same exact ones and providing that for sale. So if there's any interest in that, contact IOL for that particular design.
Yeah, makes sense.
On the CBB, so the PCB material is en route to our assembler. We're targeting a May 15th to Dell. Right now, I don't have a single integrity resource to test that. I believe I may have one vendor that is willing to do an early look at that. If there's any other vendor contributor that is willing to provide assistance and present public information, let me know. You can reach out to me directly or state it here. Ideally, it'd be great if a NIC vendor is one of those other volunteers. Otherwise, even a test fixture vendor or a test and measurement vendor as well. But I hope to have some data to present for the June update on that, depending on if we can get some volunteers. Okay.
Yep.
Lastly, on next slide, I had presented this prior, but we have the TTF as well as some other test fixtures that we hadn't released, one of them being the LED test fixture and then the system management test fixture. They have microchip MCUs on these boards. Dell had developed some early base firmware, but what we've done is we've contracted a company to develop firmware that can be released to the open source community. The thermal test fixture is ready for release. I know we've had it available to a couple of NIC vendors to look at. No other issues have been presented. I have reached out to Michael Schill, and he's connecting me right now. So probably next week or week after, we'll have that MCU firmware released to the public. It'll be on the OCP GitHub. And once we have that released, we'll start looking at the other boards that we have. There's other two boards, we haven't released those to Wiki. And then in the middle of all this testing, we found one little minor issue on the LED test fixture that Intel's also been contributing with. We'll likely spin that board and then just release those items. I know, Damien, you asked if I'd present an update on that, but unfortunately I just haven't had a chance to put some slides together on these two fixtures. But they were presented, I believe, at the prior, it wasn't the prior summit, it was one of the other regional summits prior to that. And then I didn't really update the bottom part of that, but that was something I stated earlier about any need for, mainly that IOL has the ability to provide these fixtures for sale, but they don't necessarily provide the technical support. The stopgap has been if we can at least provide users guides, they can at least point them to those users guides. And I think that's a good idea. Like I said in the last meeting, that these are great if you have summer interns in your hardware lab that are needing something to do. this is a great way that they can help provide some context for various test technicians on how to use this and actually release that into the open community. That's something that likely Dell will be doing with some of these other items that haven't been released yet.
Thanks for signing up that. Yeah. Unfortunately, Meta this round we will not have any summer interns. At least for our group.
All right, well, thank you.
Yep. Thanks for the update, Jason. And yep. Yeah, we do have quite a few of the folks from iPass Lab actually on the call. Yeah. This SF fixture could be similar to what iPass Lab is having. Yeah. If you have the bandwidth to help qualify it, then maybe that could help. Thank you. The next quick update. Oh, where is that? Sorry. Yeah. Next up, we'll talk about the thermal test fixture for Torch form factor. We do have offline discussion between Intel, Dell, Meta, and NVIDIA, mainly the thermal folks and some system folks, to see how do we resolve the inaccuracy problem that NVIDIA have brought up. So I think we do have a proposal. This slide have not changed. It's more like a background for those who just joined us um, this month. So now I want to move to Anna to provide the updates on the result. Anna, do you want to share this, your slide?
Oh yes, I'm sharing my screen and
Yep, I made you a presentation. You should be
okay.
able to present.
Tell me if you see it.
Yes, we can see it.
Okay, great. So this is my slides. I just want to remind you that we're talking about TSFF thermal test fixture, and there were a few differences between SFF and TSFF test fixture. So the front panel, the bracket area was completely changed here. And now in the new TSFF test fixture, we have only two cards, identical cards that are both OCP3, and only the top one is under the stress, and the top one is just uses a dummy card for geometry. And you can see here on this picture the TSFF test fixture. It's from my thermal simulations, and the old SFF test fixture. I think this is from OCP spec. The problem that we saw during our thermal simulations and thermal tests is it's definitely it is problematic to measure the airflow in this new test chamber with these changes because you can see here on the left side hot airflow direction, and you can see here a few bypasses. So here the airflow that goes to the side of the cart, and some stage just returns into the cart area, and we'll see later it adds additional cooling for the cart, and it's not the best case, not the typical case for what happened in servers, as I understand, and from what I saw in the servers. An additional problem is regarding the cold aisle airflow direction. You can see here on these streamlines, it's impossible to measure airflow with these candlesticks. So I also wanted to find another way and another configuration how we can measure the airflow for cold aisle as well. What I simulated, I ran the simulation for both airflow direction, hot aisle and cold aisle, because both of them are really important The ambient temperature was the same for both airflow direction, because what is really important here is the differences and not the absolute numbers. I used only passive cables to simplify my problem, so we will look only at the ASIC temperature. And at the first stage of my simulation, I simulated two test fixtures. One of them is a TSFF test fixture, and the second one it's one slot test chamber. I use this only as a benchmark, just to see the differences in the airflow, because as I see, this is the case where all the airflow that enters the area of this chamber uh, passes through the card. It's kind of best case scenario because you don't have bypasses there. So other solutions should not be significantly cooler than one slot enclosure. Better not to be cooler at all. This is two enclosures. This is a big one. It's a TSFF. This is a small one. It's a one slot. You can see here these brackets, so you have only one card inside this fixture. And I used here at the both cases the inlet airflow as a boundary condition. So I just put here on this edge the fixed airflow, and I put the 300 LFM, 400 LFM, and so on for both cases. So the average cross-section velocity is the same for both fixtures. And I also simulated two different geometries. One is Connectix 7 with QSFP DD cable, and one with its Connectix 7 ASIC with OSFP cable, just to see if we see the same trends for different geometries. These two geometries are not completely different, but still, here we have bigger heatsink, and here you have bigger cable and also heatsink on top of it. So I would say the geometry 2 just has just more density than geometry 1. Here you can see the results and comparison between one slot test chamber and new TSFF slot chamber. The problem that I see here from my side, it's a significant difference in the temperatures between these two chambers, and the new TSFF test chamber is significantly cooler, has significantly lower temperatures for the ASIC. So I'm afraid that this result that we see in this simulation is just too optimistic results. And it happened because of this airflow behavior that you can see here. So at the entrance of the card, you can read here with all these candlesticks, for example, the airflow is really close to our boundary condition, so around 400 LFM, 500 LFM. But then this air that was here on this side just enters the airflow. It's kind of, we have additional airflow, but we just don't know about it because we didn't measure it.
Yeah,
And
makes sense.
yeah, so that's why I think we see this trend. And for geometry 2, we see a similar trend. Although here for hot aisle airflow direction, these two curves are much closer one to another, but for cold aisle, we see the bigger difference, almost 10 degrees Celsius, 8 or 9 here for 300 FM, for example. It's a huge impact. And I thought how I can to improve this situation, how I can to improve this TSFF test chamber, so we will not have these bypasses, or will have these bypasses, but the airflow will not come back to our NIC area. So what was my requirement for possible solutions is that the results should be closer to the one slot enclosure and not to the current TSFF. We also prefer not to do significant mechanical changes in the current test chamber structure. It's something that's really obvious for all of us. We don't want to change it a lot. And also the additional thing that I thought about it's maybe to add another possibility to measure the airflow, not only with candlesticks as described now in OCP 3 spec, but also with the we call it air bench approach. So when we measure the total airflow number at the entrance to our test chamber with the air bench, we saw here that it's improved our calibration process. We saw that these measurements are more accurate, and it's also something that helps us to evaluate cold aisle airflow direction. It's very critical for part of our customers. And one of the solution, and I shared it previously a few months ago, just to add air buffer inside the test fixture. And in this situation, we just ensure that all airflow that we push here and the boundary condition just go through the cards. We need to make here some difference. So if we push here the, for example, total airflow, we need to calculate the CFM according to this internal cross-section area, because this is our effective cross-section area when all airflow goes to our cards. And the second solution is a side holes solution. So here we just simply open a few holes, put few holes on the sides of our test chamber, and we just want to allow the airflow, the part of the airflow, just to flow to the sides and not come back to this area of the bracket. So all this airflow that was on the sides of the our nick car just should continue to these openings. And here you can see the results for geometry 1. Both solutions, both possible changes are much closer to one slot than just the new TSFF test chamber. So the let's say it's close to the real picture, real results. What we see here that Aeroduct TSFF has a little bit closer results, a little bit better results. It's a little bit closer to the one slot. And this is the second one. We see here the same trend. And we also see that side hole solution, once it's a little bit hotter, once it's a little bit closer, but still here at 310 the difference is less than 3 degrees Celsius or something like that, and not 8 as it was for new TSFF. So it's still better. I also wanted to check, because when I simulated it initially, I put boundary condition at the entrance, because this our approach when it's how we in NVIDIA prefer to measure airflow, just total airflow, and then divide to our cross section and see what was the LFM in the cross section area. So I wanted to check if this boundary condition approach can be similar to the readouts from candlesticks. It's really important to say here that it's only based on simulation, so I put a few monitor points at the area where candlesticks are located in our 3D model. And then I calculated the average of all three candlesticks because our geometry is not symmetric, so there is some differences between the candlesticks readouts. But you can see here on these tables that for both geometries and both solution of changes of TSFF, the readouts of candlesticks really close to our boundary condition, at least in theory. Of course, when we decide about our changes and we would like to check what we really read with the candlesticks, we can run some tests maybe and measure and see again if we have some problems or not. But at least theoretically, we don't have problems. We can use candlesticks to measure the airflow that enter in our nick. And also we can just calculate the required CFM and push this CFM with the air-bench system. Here on the table, I just wanted to compare between two solutions, one of the air duct and one in the holes. Both of them in general allows to measure total inlet airflow with the air bench or with the candlesticks, as I showed it in the slide before. And also we can run a cold aisle simulation, at least for total airflow measurement. So we can put this boundary condition and we can assume that the airflow, average airflow in the nick was the average airflow that we can calculate from this boundary condition. I don't know how we can use candlesticks for cold air tests. We need to think more, maybe to run some tests to understand it, because it's very tricky and not straightforward. I don't have straightforward answers for this. For air duct, we have a more significant change in the our test fixture. But for the holes, the change is relatively small, so only the front panel is affected. So it's not such a big deal, at least as I see it. The air duct is the most accurate, gives us the most accurate airflow measurements. So the results are very close to our one slot. But although for holes, the measurements may be less accurate because we see these different trends. Sometimes it's a little bit hotter than one slot, sometimes it's a little bit colder. But I think that the overall, the airflow just is more typical for servers because we have some amount of the airflow in the entrance, we have a bypasses through the cars, but all this airflow that goes to the sides of the car just continues to other opening in the front panel. And I think it's just more typical situation that we can see in a bigger system. And again, air duct just either for nick calibration because we sure about the amount of the airflow that enters, and it maybe also can help us for initial design simulation because we can run only only one slot instead of simulated the whole test fixture. But it's not as important. And I think we can discuss here which of these two solutions are better. I definitely, although I really think that air duct just gives us more accurate results, and as a thermal engineer, I want to be as accurate as I can. I still think that maybe the whole solution just better for us because it's easier, it's smaller update for our task fixture, and maybe it just describes better the airflow into the bigger system, into the servers. Um,
I see the benefit of like the being closer or more typical to server as one of the benefit for hosts, like the non-ideal to a certain extent. That's one benefit I see for hosts.
yeah, I agree.
And maybe a second benefit of hosts is also consistent to what our prior SFF thermal test fixture
It's
is.
closer, yes.
Yeah,
It's closer to our previous because the previous SFF test feature had really a lot of openings
yeah, and we
near the
intentionally put those
card.
openings there too, because to more mimic the server earlier.
Yeah. So I also think that it's another good thing maybe why holes are better than Aeroduct.
And I believe this is the last slide, right, from you?
Yes, yes, yes. I think
Yeah.
that just
So yeah, I want to conclude one thing is like I think so given that our tall small form factor thermal test fixture have this that could give you more optimistic result to more like sharing in the community. I think this is something that we need to let everyone know. So that there may be a need for you to look into this or even change your thermal tier profile because like the test fixture give you a better result than it actually is. Yeah, this is something that um, I think the folks in the community would like to pay attention. If you already have a TSFF tested in our TSFF thermal test fixture, yeah, that you might need to go back and relook um, into updating the thermal tier. Uh, yeah, and yeah, I will post the ANA's result later on. You can roughly can see how much difference that we expect between the two. Yeah, this is more important for those who already have a TSFF uh, NIC in the market.
we in general have a few TSFF, but because I knew that we have this problem in the task fixture, we did some shift to the total airflow to be closer to the one slot and not to be too optimistic.
Yeah, that's good that NVIDIA found out did it on your own NIC and share the community. That's actually a very good thing to do. I appreciate that. Yep. Next, we work offline. Perhaps with uh, Dell to update the thermal test fixture design, and we can test it out in real system and then come back to report.
Excuse me?
Okay. Yeah. I mean, we can work out the actual changes and then we can test it in real system and then come
Yeah.
back. And yeah.
But I think we need here the mechanical engineers of this TSFF test feature because
Yes.
to add these holes to our the places, maybe to see what the impact of this change on our mechanical design.
Yes. Yeah, depending how thick is it, maybe Meta can help too. We do have some laser cutter in Austin. Okay. Yep. I'll follow up with NVIDIA and Dell offline on this. Cool. Thank you. Let's move on to the next one real quick before we pass it to iPass Lab.
Okay, hello everyone.
Yeah.
Yeah.
Yeah. Real quick. Let me talk about the SmartNIC Summit. Then we can pass it to iPass Lab.
Okay.
So, yep. Thanks, Eric. So, yep. The SmartNIC Summit will help next month in San Jose. So earlier we talked about we'll have demo and presentation. After talking to some hyperscaler using SmartNIC currently, I also get some feedback and discuss with um, Dell and NVIDIA who actually participating together in the SmartNIC presentation. Felt that it's actually not suitable to push small factor and tall small factor as the SmartNIC solution um, for the form factor solution, mainly because like it doesn't have enough space and thermal cooling capability for majority of the SmartNIC use cases. And then while our large form factor could be it, but you also know that most of the server doesn't support large form factor. It felt like it would be not a good thing to the community, especially the SmartNIC community, that we push the SmartNIC using our form factor, but it's actually not that good um, as overall. As such, I really align with Dan and NVIDIA that we actually arranged to have the SFFTA 1034 or the PMM to present their form factor, which is a lot of it, honestly, actually take a page from the OCP NIC as well. They also plan to support a NIC on that form factor, intentionally for smart NIC use cases to present in the summit. That said, yeah, NVIDIA will still go to the smart NIC summit on behalf of us to gather feedbacks. That's the update for the smart NIC summit. And then next, we would like to pass it to iPass like to talk about their SI test fixture and also test service as well. So this is mainly from like we initially partner with UNN IOL, but they are never provide this service for PCI Gen 5. So it's good to hear from iPass Lab, which is providing this service. Eric, please take it away.
Okay. Okay. Hello everyone. I'm Eric Sun from iPass Lab, and currently we have our member here. Nina is our marketing manager, and Ike Liu is our senior application engineer, and he will present the OCP text feature later. And David Chen is our AE manager, AE technical director. So thanks for bringing us to join this meeting and present our service and test feature. So I can share just quickly introduce the service of iPass Lab at first. So can I share my screen at first?
Yeah, I think it's currently sharing, right? Oh, I mean,
So
okay.
can everyone see my screen right now?
Yes.
Okay. So for iPass Lab, right now we currently is a candidate, one of the candidate of a authorized test lab of PCI SIG. So we host a Go Suite during February PCI workshop in Taiwan. So right now we provide a PCIe test service for IC design house and system vendor in Taiwan. But because we have not only Keysight real-time scope, 70G real-time scope, and we also have Tektronix and the LaCroix 50G real-time scope in our lab. And in the meantime, we also have enriched 32G NRZ bird and painful bird up to 64G BAW in our lab as well to provide not only for computing enterprise, but also for datacom. So we right now provide the service in digital interface like PCI Express, USB, SATA, SAS, HDMI, and Thunderbolt. And also we provide the test service on TX and RX for 100G, 400G, and 800G applications. So this is our service in Taiwan, based in Taiwan, and we right now service to the global market. Okay, so I will give the screen share to Ike to present our OCP text feature.
Yep, thanks.
Okay. Ike?
Is my screen go through yet?
Yeah, we can just see your screen now.
Okay. Okay. This is our agenda for today. Currently, we basically we will do our test feature based on the PCIe roadmap to develop the schedule and based on the spec from the SIG they released, we will do our design, loss budget allocation, and the material layout rule. Wait, and the connector. Yeah. So the for this part, currently we had, just like Eric had said, we had already provided M.2 and U.2 text feature for C to do the correlation, and currently the impedance and the insertion loss looks good, but there are some feedback from the SIG, such as the SSC function for the reference clock we need to add on for the next generation, for the next version, CLB and CBB. And this is our text picture development. And basically, we had already really verified and released all of our non-CAN text picture currently, and we will see is there any feedback from the customer, and we can improve our text feature on the next version. And currently, the new version of M.2 and U.2 had already done, and the OCP will be the next one, and probably in a month or so.
Oh, you mean your OCP test picture is not ready yet?
It's ready
No.
for the first version, and the next version will be.
I see.
Yeah.
The first version not including SSC function on the C part, yeah, and we will add in the SSC function to the CBB on second version.
I see, got it.
Yeah. And this is the loss budget from the SIG. And for our text feature, we use the ultra low loss material and the microstrip line. And the loss budget currently is 36 to 30, around 36, and 9.5 for Edinca and 26.5 for Season. And in Edinca, there are 4 dB package loads and 9 dB package for Season.
And this was defined for CAM. This slide was defined for CAM.
Okay.
So for
Yeah.
OCP, we will present on the next slide.
And this is what we the spec for the OCP. The Edinca is 7 dB for 30 dB. So based on this, we design we design our test feature based on this spec.
Yeah, that's right. That's what we have
Yeah.
in our spec.
Yeah.
The intent is because the card is smaller, so give more budget to the system.
Yeah. And the next 2 pages will be the loss budget for system and the Edinca from the SIG. And for OCP, we basically for system board, no matter the transceiver or receiver testing, we'll keep for calibration, we'll keep the CVB side at 30 dB, and the Edinca side, the COB side, will be the 4 to 7 dB to choose which ISI pair is the most suitable insertion loads to meet those criteria. And the 4 to 7 dB will be included the RX trace, the AMPX table, and ISI trace, and the connector. And the next page will be the Edinca. For the Edinca, we'll keep the COV side at 7 dB insertion loss and choose the ISI pair to meet 27 to 30 dB loss. And those would be including the connector, the arc trace, CVV, the ISI pair, and the connector. Yeah. And the connector what we use is based on the Intel release document for the data for transceiver for the TX and the RX differential pair. We use Ubiquitous and PX connector, and for the clock we use SMA connector. And this is our CLB, and our CLB will be separate. There are 16 lanes. We will separate. It will be in 2 CLB. For the left side is lane 0 to lane 3, and lane 8 to lane 11. And the other side is lanes 4 to lane 7 and 12 to 15. So the blue part is the reference clock output, and the red one is the toggle button, and the gray one is the toggle signal output. Usually this would route to the receiver, depends on which lane you are testing. You are doing the transmitter test, and the TX will be go to the for TX test will go to the scope. Yeah. And the next page will be the CBB. The basically the main difference is our long short channel for loss per inch calculation we put on the CBB, on the side of the CBB. And those parts can help us to know how is uh, the transmitter RX and TX loss.
Yeah, so no matter CLB or CBB, the long channel and the short channel uh, will be in the or no matter the long channel or short channel trace, it all on the CBB. So you can reference the CBB long channel and short channel. You can calculate the loss per inch of the CLB and the CBB through CBB long channel and short channel.
So
And
how
this,
do okay, continue first.
okay, okay. On the next
So
one, okay, sorry.
uh, are there any question from you, Tommy?
Yeah, I was wondering, like, as I understand initially, you provide the test service as your business, and then you also sell the test fixture, right? So this is the two things that you do. Is this still the correct understanding?
Yeah, the originally because we need to service we need to serve to our customer and
Mm-hmm.
our customer including the server and the storage vendor, and
Mm-hmm.
they need the test feature for different form factor, and
Mm-hmm.
PCI SIG only release the test feature for CEM only.
Yeah.
So
Right.
that's why we design the other form factor for our customer use. So and based based on the request from customers, so we send the text feature to PCI SIG for certification, and PCI SIG only accept M.2 and the U.2 because they say the other form factor uh, is not for their business, right?
Mm-hmm.
So
Mm-hmm.
yeah, so right now our U.2 and the M.2 test feature is under certification from PCI SIG SEG Serial
I see.
Enabling Working Group. Yeah, so we also sell those test features to our customer in Taiwan, and also through Keysight, Tektronix, and LaCroix. They also want to service to their customers, so they also
Mm-hmm.
purchase some test feature from us with
Okay.
their solution to customer currently.
Sure. Makes
Yeah.
sense. Okay.
And the next is the compliance mode toggle signal. It is the just like a millisecond duration of the 100 megahertz reference clock, and it will be routed to the receiver lane. Depends on what lane you are testing, and you will change the pattern from Gen 1 to Gen 5 at any
Mm-hmm.
preset. Yeah. And the next one is the reference clock, and just like we told before, currently, the current versions CBB, we don't have the SSC function on it, but we will add this on the next version CBB. And the following is the CBB came from SIG, the 0.05% and the 0.5% downspread SSC. We measure it, and later on, when we got our new versions of the uh, OCP, CBB, we will double check that and to meet the spec with the CBB. And here's the last slide.
Okay. I think it's good to have a contact information in the slide deck. So, for folks that is interested to use your service or to purchase the OCP NIC Gen 5 fixture, then we have a way to contact.
Okay, thank you. And if the working group need the sample for the certification or doing some experiment, then we can offer one kit or it including a COB and CBB to the working group with no problem.
Okay. Yeah, thanks for the offer. Before we say yes, I think we need to figure out who to actually use it. You probably heard just now that we do have the else kit that we are actually looking for volunteer to test. So yeah, before we take a kit and then put that, we need to figure out who to test first, and maybe even do some comparison. Yeah.
Okay, thank you. So any question for this?
Not from my
Okay,
side.
thank you everyone. Yeah.
Yeah. Yeah. Thanks, Eric. Thanks, Pastor, for coming in to share a solution, especially when we lose a UHL as a test solution partner.
Okay, no problem.
Okay, cool. Yeah, that's it for this month. So yeah, I see you next month. If anything, do send me email. Thank you. Meeting adjourned.
Thank you.
Take care.
Thank you.
Thank you. Bye bye.